Welcome to Cryptography 101. Today we're diving into the foundational concept of substitution ciphers. Let's start with the basics of what a substitution technique is in the context of encryption. A substitution technique is an encryption method where the original letters of the plaintext are replaced by different characters, which could be other letters, numbers, or symbols. The key idea here is that the identity of the character changes, but its position within the message stays exactly the same. For example, in hello, H is replaced by X, E by Y, and so on. Think of it like a substitution in a football game. Player number 10 comes off, and player number 7 goes onto the field in the exact same position. The character identity changes, but the position is constant. It's important to distinguish substitution from the other main type of cipher, transposition. Substitution involves replacing characters, while transposition involves rearranging characters. For instance, in substitution, A might become Z, but in transposition, A remains A, just moved to a new spot. In substitution, the character's position stays the same, but in transposition, the position changes, similar to shuffling a deck of cards or creating an anagram. Substitution ciphers are generally classified based on how many alphabets are used for the replacement process. First, we have monoalphabetic ciphers, where a single rule applies consistently. If A is replaced by D at the start, it is always replaced by D. Conversely, polyalphabetic ciphers use multiple alphabets. The replacement rule changes frequently. A might become D one time and X the next, making the pattern much harder to follow. Each technique has its own strengths and weaknesses in terms of security and usability. Simple substitution ciphers are easy to do by hand, but they leave the structure of the original language intact, which is a major security flaw. Polyalphabetic ciphers, on the other hand, hide the frequency of letters, making them much more secure, though they are complex to manage without a machine or a tool. The main weakness of simple substitution ciphers is something called frequency analysis. Frequency analysis is the Achilles heel of simple substitution because it exploits the common statistical nature of human language. For example, E is the most frequent letter in English. A hacker simply looks at the ciphertext. If a certain symbol, say the hash symbol, appears 13% of the time, they can confidently guess that the hash symbol corresponds to the letter E. Polyalphabetic ciphers defeat this attack because the letter E is replaced by many different characters throughout the message. This makes the frequency graph appear flat, preventing the hacker from making confident guesses. To wrap up, let's review the concepts and try a quick practice question. Remember, substitution changes identity, while transposition changes position. Monoalphabetic uses one rule. Polyalphabetic uses many, making it more secure. If you intercept KHOOR and suspect a Caesar cipher with a shift of 3, the plaintext is decoded by shifting each letter back by 3, revealing the answer, hello.